I am going to suggest that you take your binders, clear them out with whatever stuff you have in there from this year. You can recycle them if you want, have a bonfire, whatever, keep them because you want to study it. But I would recommend emptying it out, putting all the Regents exams I've given you in there with this sheet right on top. Okay, this sheet right on top. You guys see when the Regents is? Tuesday, the 19th from 8 to 11 in Gym A. I'll have your seat number either tomorrow or Friday. Okay, probably Friday. All right, I am a little nervous about having it on Tuesday, June 19th, because it is the last exam for you guys. I get a little nervous about that because I don't know what... It's the last exam you guys are going to take, which means our last meeting date as a whole group is going to be this coming Monday. Okay, well, maybe it's not the last. But regardless of if it's the last or not, I'm going to meet with you guys next Monday. That's it. I may not see some of you until that Tuesday, and that makes me very, very nervous because I don't know what you're doing in between. All right? But being in an honors class, maybe I shouldn't be so nervous, but I am. Supply checklist, I'm not going to read them off to you. That's what you need. Now, I have seen recently, over the last couple months, a lot of borrowing of the calculators that come up here, all right, that are up on the front. Here's the deal. If you need to borrow a calculator, you're coming to a review session in exchange for a calculator. Okay, that's the deal. If for some reason you need to borrow a calculator, I have no issues with that, or a compass for that matter. You're coming to a review session and staying for a little bit. That's the little give and take I'm putting out there for you. All right, so keep that in mind. Monday night before the test, I would highly recommend going through the checklist, making sure you have everything ready to go. Okay, tomorrow we'll practice clearing the calculators like we did for the midterm, making sure you're in degree mode, tomorrow I'll talk more about pen versus pencil and what type of questions, etc. I want to get through everything though today. So everyone good on your Regents exam checklist? I would put that right in the front of your binder along with all the other tests I've given you. All right, here we go. Under the Regents review folder, you have a folder that says constructions. There's a link to the YouTube video which covers all the different constructions we've done. You can look them up yourself. All right, I don't know how much time I'll have to go over constructions, and personally, I don't want to go over constructions in class. They take 10 minutes, and then I don't get to review another important topic versus something you can just go on that Mrs. Venezia and I created last year and watch how we did them. All right, so I don't know how much constructions I'll be going over in class. Next thing on the website here is 2 extra online Regents tests that I won't print out and hand to you. If you've done all the Regents exams and you're like, I just need more, I want more practice, I understand. I put 2 extra online ones up here. All right, practice test 1, practice test 2. And it's actually not that bad. Like if you go to the multiple choice section for, let's say, test 1, you can sit there with your notebook, try out the questions, figure out, what are the answers that you want. And then once you're done with all the multiple choice, it'll go ahead and score it for you and tell you which ones are correct and which ones are incorrect. So pretty nice. All right. So there's 2 extra ones. Regents review times. I don't know how often you guys check your Bethlehem Schools email, but yesterday during the day, I sent out to both you and your parents all my Regents review sessions that I'll be holding. All right, starting this Friday. There are late buses. I just want to make that clear to everyone in case transportation's an issue. There are late buses this Friday and next Monday. And then I have some during exam week. I don't know if you guys are free or not. I didn't really check the exam schedule, but that's when I'm going to be free. Next Saturday, I'll be here from 12 to 2:30. And then Monday before the test, I'll be here in the afternoon. And I may regret it, but I'm coming in here at night from 5:30 to 7:30 if you guys want a last minute review. Okay. I will not be here the morning for the test. Okay, so our test is at 8 a.m. I'm not coming in at like 6:37. Okay, if you want to add all these up, 14 and a half hours of review I'm making myself available for. So it's really up to you. Okay, we will grade the Regents exam the day after on Wednesday. I have no idea when the scores will come back, maybe late Wednesday night, probably on Thursday I'll have them. All right, any questions about that copy? And you guys have it in your school email too. I sent everyone a copy. Questions, comments? All right, good. Let's see, what else do I have up here? Oh, remember back in February, March, April, I always used to assign a couple Regents problems out of a packet on here. And then some people just started not doing it, and I got frustrated and canned them. Well, those questions are now back up here, all 315. Not only are the questions up here, so are the answers now. Okay, the answers follow all 315 questions that are there. By the way, just so you know, you may see these over and over. These are Regents questions, so they're in your Regents exams too. They're just all put into one file now. Okay. And then your checklist, and then hopefully you guys have been using JMap to check your homework answers last night. Now, I understand that sometimes the person who writes the answers doesn't do a detailed response, or maybe just circles a multiple choice and doesn't write down how he or she got it. I don't know. But so I found a different website if you'd like. You can go to this website where it says Regents Exams and Video Solutions. Not only will they have solutions, but a teacher pops up. It's a little corny, actually, but it gets the job done. A teacher will pop up and explain the topic and why the answer is what it is. So it's actually a video solution instead of just a handwritten solution. Okay, so you can go to any exam, like we're in the August 2017 one now, and you can have video solutions to any of the questions that are on there. Okay, so a guy will pop up, hey, this is how you do number 12, etc. Okay, I thought that was nice too. All right. Questions about that at all? So a ton of resources up on Aspen for you guys, ton of resources. Any questions about those? Okay, there you go. I'm not going to talk about them anymore. You guys can shut the Chromebooks down. As you saw in Aspen, I did grade your surface area volume test pretty quickly yesterday. I just have about 6 people that need to take it. So once they take it, I'll hand them back to you. Okay, before I get into today's topics, if you borrowed a textbook, you may want to start bringing them back, unless you plan on studying from it, which I don't know if you will or not. But if you borrowed a textbook, I have the names of everyone who did at the beginning of the year. You can start bringing them back to me. Okay, so start bringing back your textbooks to me. All right, let's get right into the review. We had some multiple choices and a couple free responses last night. Hopefully, again, if you don't check them, you guys know where to check them. You got JMap, and now you have those video solutions that I posted on Aspen. Anywhere you want to go for a little bit more explanation than what you saw. Madeline, here we go. Start us off. 10, everyone. Here we go. Go to number 10. All right, here we go. Let's buckle up. Comes pretty strong in the next couple of days. I'm dilating a line. Anytime I dilate a line, that line stays parallel to the original line. Please remember that. Anytime I dilate a line, that line stays parallel to the original line. All right, stays parallel, which means what about their slopes? Same slopes. So that was the key to this whole problem here. Oh, you want me to dilate a line? Fine. And really, it says centered at the origin. In this case, I could have centered it anywhere. It's still going to be parallel. Doesn't have to be centered at the origin. Can be centered around any point. Still going to stay parallel. So up here, 4y equals 3x plus 7. This is the line I'm going to dilate. How can I find the slope of this line? Divide everything by 4. 3/4 x plus 7/4. The 7/4 doesn't mean a darn thing in this case. The fact that the slope is 3/4. So I'm going to look through my multiple choice right now and figure out which one will have a slope of 3/4. Okay. Quickly go to number 1. How do I move that 3x over? Subtract it, right? And it would be negative 3x. And then I divide by what? Negative 4. So what ends up happening here? Positive 3/4, which matches my slope here. So that's why it's choice 1. Did you have to solve for y? No. If you knew it was the same slope, you could have just got x and y on the same side and figured out where the signs were going to be the same. All right. So anytime you dilate a line, they stay parallel to each other, which means their slopes do not change. Here we go. Let's keep this going here. This is your show here. I do have a bunch of problems I want to try with you, but we can get to them when your questions are done. Start thinking about topics too as well. Start saying, hey, I remember this topic, and don't just say quadrilaterals. Get a little bit more specific than that. All right, I'll go over anything you guys need to. Next up, anything? Yep. 2, everybody. Okay, 2, which transformation will the triangles not be congruent? I'm sure most of us narrowed it down to 3 and 4 because we know a dilation changes size and shape. But here's the catch here. Dilation on number 3, what's your scale factor? 1, it just stays where it is. Okay, versus 3.5, that would be 1.5. Now it's getting further away, which means it's getting larger. Dilations that are centered at the origin means I can take my scale factor and multiply the coordinates by it. I can't do that if it's not the origin. I actually have to, find, do the slope, and then either, depending on what the scale factor is, double it, triple it, cut it in half. All right, but with the scale factor centered around the origin, you can take your scale factor and multiply by whatever it is. Okay, but I can't do that unless it's around the origin. More questions here. Let's keep it going. Nothing else. We sure. Let's go, Rose. 26, everyone. Okay, had to know our rhombus properties here. Good little review question. Okay, we have a rhombus PR, diagonal PR, 16, QS, 30. All right, let's start listing them out. I really don't want to call on people right now with the number generator. So here we go. Properties, diagonals of a rhombus. So you should know 3 of them going into a couple Tuesdays from now. 3 properties of the diagonals of a rhombus. Saad. Perpendicular. They are not congruent. They are not congruent. That is a rectangle and a square. They are not congruent. That your side is correct in saying they are perpendicular. Got it. Next, another one. Evan. They bisect each other. So this one, a PR that's 16 is going to be cut into 8 and 8, and the QS of 30 is going to be cut into 15 and 15. There is one more I'm looking for. I know it doesn't apply to this problem at all, but I still want to know it. Frank. The diagonals bisect the angles they're drawn to. Okay? All right, let's get back to the problem. It says find the perimeter. Anybody want to explain why I do not need to find all 4 sides? Madeline. Another property. In a rhombus, all sides are congruent. So if you just find me one side, you multiply it by 4, you got the darn perimeter. How do I find one side? Using Pythagorean theorem on one of the right triangles. 8 squared plus 15 squared. The side is acting as a hypotenuse, c squared. And that came out to be 17. 17 times 4 gives you your perimeter of 68. No units. Nope. 68. Properties of a rhombus. While we're here on the rhombus, area of a rhombus. While we're here, might as well throw it out there. 1/2 diagonal 1 times diagonal 2. Just throwing everything out there. Pride myself in taking every scenario and throwing it at you guys. Anything else with the rhombus I think we need to go over? I think that's about it. Next, anything else before I go over my problems from this exam? I got a couple problems I want to do with you. Okay, first one's number 30 today then. 30. I'll let you read through it. All right, prove to me a BC is congruent to YZ. Ready to roll? It says a sequence of rigid motions maps A to angle X. Stop right there. What do I know about angle A and angle X? Be able to back yourself up too. What do I know about angle A and angle X? They are congruent. How do you know they're congruent? Because what put A to X? A rigid motion, and what do you know about your rigid motions? Preserve angle measure, so they have to be congruent. Got it. So A and X are congruent. Give me another pair that are congruent. C and Z are congruent. And I'm just talking this out. We'll write it all down in a second. And what other pair are congruent up here? AC congruent to. Look at those two triangles. Want to tell me anything about the triangles? They're congruent. What method? Method? Angle, side, angle. Finish it. Y is BC and YZ. CPCTC. It's like a little mini proof here, except I don't have to do statements, reasons. I'm going to write it all out now. All right, so first thing, angle A congruent to angle X. Angle C congruent to angle Z. And you don't need this word for word like I'm doing it up here. There's a lot of flexibility in your answer. And we also found out that AC was congruent to XZ. How do we know that? Because rigid motions preserve. What do they preserve there, kiddos? Side length and angle measure. Now what do you know if those three are congruent? What do we say next? If those three pairs are congruent, that must mean your triangle. So triangle ABC congruent to triangle XYZ because of angle, side angle. What do you want to throw in there? Thus, so therefore, henceforth. I hope we get to use that. Henceforth, BC congruent to YZ by CPCTC. Only mistake I've seen on this problem is students will say the triangles are congruent because rigid motions preserve distance and side measure. It doesn't say the triangles were mapped onto each other. It says the angles and the sides, okay? So you cannot say the triangles are congruent because of rigid motions. All right, it says these angles and that side were mapped, not the triangles. Questions, comments? We all good there? Hey, let's keep this train rolling. 17. Everyone's favorite. Partitions. What are the coordinates of point P such that AP to PB is 3 to 5? Let's break those points up into a ratio of 3 to 5. Just a reminder, you guys will have one sheet of scrap graph paper attached to your Regents exam that you are allowed to rip off and use whatever you want. Okay? I would recommend at the end when you get your coordinate, because this might not be multiple choice, it might be a part 2 question, is actually plot your partition point and make sure it's on your line. Okay? Because if it's not on the line, it's obviously incorrect. All right, so let's start with the x coordinate. Anybody want to lead me through, like I've never been here this entire year, how I figure out what the x coordinate is? What are your x coordinates of A and B? -8 and 16. Okay. How far are you going? $16 units? I think a little further than 16 units. From -8 all the way to 16 on the x-axis. Rico, how far am I going? 24 units. Darn right we are. All right, what are you doing in that 24? Divided by 8. Why 8? Good. 3 to 5 means 8 congruent parts. Now, I've debated about this because I have found a quicker way to do this, and I don't know how confusing my way originally was. Because after you divide it by 8, what are you going to multiply it by? Everyone agrees? So what you could do right now, and I'm just going to show this, you decide what you want to do, is just take your 24 and multiply it by 3/8. That'll tell you how far you need to go. Because you're going to divide it by 8, right? And then multiply it by 3. So why not get it done all in one step and multiply by 3/8? 3 divided by however many parts you need to go break it up into. What's that give you? That should give you 9, and that tells you got to go 9 units from your starting point. So I don't know if that's a little quicker, convenient for some of you guys. If not, keep doing it the old way. Where was my starting point? So -8 plus 9, 1. And really, we could end it here, right? Because why could I just end this here? I only have one answer up there. But hey, let's do the y coordinate. Come on, I was going to say we're not slackers, but that might be untrue. -2 to 6, how far you're going? 8 units. And again, I'm still going to multiply it by 3/8. That gives me 3. And then -2 plus 3 gives you that 1. Please, warning, don't use the second number in the ratio. Okay, a lot of people use the y coordinate and they think they got to use that 5 instead. No, you don't. Do you know when you would use the 5 instead? If you're going from B to A, guys. B to A, you would use the 5 instead. Okay? All right, so continually use the first number. All right, 20. How many people remember our formula? Okay, which states have the largest, the smallest? And I'm hoping just like you're not thinking about a map and saying 1, 2, 3, 4. All right, let's do this out mathematically right now. Which states are the largest? I got population, I got population density. You remember what population density was equal to? And they kind of tell you right here in the problem, but population over land area. Okay, population over the land area. So we are giving you the population density and the population. I'm really looking for you guys to solve for the land area of each of them. So let me do Florida with you. All right, let me do Florida. Population density for Florida is 350.6. There's the density. It's equal to the population, 18,801,310. And you guys are looking for the land area. How are you going to solve this? Because I'm afraid some of you guys are just going to multiply and that's it. And that's not where we're going with this. You're going to do 350.6 x equals that 18 million. And then divide both sides by 350. That doesn't work out well, huh? 350.6. All right, so I will let you go on your own here over the next minute and a half, and you guys be ready to rank them for me. Be ready to rank them. Got them ranked here. Which one had the highest population? You wouldn't think, but it did. Illinois, yep. All right, Illinois had it. So I guess after you found Illinois had the largest, you could have stopped. Questions with that one? Population density, just wanted you guys to remember the formula. You never know when it'll pop up. Does it pop up every year? Absolutely not, but it just popped up last August, so who knows? Population density. Last one, last multiple choice. Perpendicular bisector equation for this segment. Let's take care of the perpendicular part. That's going to involve the slopes. Anybody finding the slope of this segment right here by doing rise over run? Slope of the segment given. Up and over how many? Should be 2. It's going downhill, so -2. What's going to be the slope of my perpendicular bisector? Positive 1/2, yep. I think we could end it here if you guys wanted to go through the choices. I believe there's only one that's going to have a slope of 1/2. But let's keep going. Let's keep going because here's what I always say to myself. That's great that it's in multiple choice now and I can eliminate all 3 answers and circle the one I know is 100% correct. But what if it's a part 2 or 3 question? I always ask myself that. Could I do it without the multiple choices? All right, bisector part, meaning this bisector is going to go through the what of the line segment? Midpoint. So here we go, the midpoint. And it's just good to review the formula too. X1 plus X2 divided by 2, and then add your Y's up and divide it by 2. All right, so the midpoint here, let's see, what's that? Let's see, -2, 1, 2, 3, 4. And down here, what do you got? 1, 2, 1, 2, 3, 4. Okay, so it'll be, where's it going to end up? Origin, right? 0, 0. All right, so the equation of this line, y equals 1/2 x, because there is no y-intercept. It's at 0, 0. Well, there is. It's at 0. Which one transforms into 1/2 x? Choice? 4. Anything from you guys? Ask away here. Don't be shy here. Do not be shy. I will let you know, probably you guys are used to such a huge curve on last year's Algebra 1 exam. This curve is not very helpful. Does it boost you up a couple points? Yeah, but it's not helpful like the Algebra 1 was last year. Okay, yep.
So these aren't like the ones that we were assigned from homework that we went over, but there were 2 that I wanted to go over, 18 and 19. We don't have to go over them.
I'm sure eventually I'll go over them because I'm going to probably finish this whole exam. Okay, Evan? No, no, shouldn't. For algebra? Really? I don't think, I've never seen that happen. And another challenge too. This exam's been given, I don't know how long I've been given this exam, maybe 4 or 5 years now since it's been out. Still waiting for 100. Still waiting for 100. So if anybody wants to rise to the challenge, and we can discuss a reward too as well. I always throw that out there. All right, a reward for the 100, but we'll see if I can get it this year. It's tough to get it. It's tough. I'm telling you, it's tough. 32. I'll give you a second if you want to throw the graph up. PQR. Okay, first thing I'll let you guys do on your own. Points A and B are the midpoints of PQ and RQ. So I'll let you guys go ahead and find point A and point B now on your own. So go ahead, find point A, point B. Again, those are the midpoints of PQ and RQ. Okay, let's go as we get going here. Anybody got point A now? Point A. Go ahead, Sal. What do you got for me? -2, 3. Yep. Anybody have point B? Point B. What do you got, Frank? 1, 5. All right. Make sure we have those midpoints, A and B. All right. Prove to me that AB is parallel to PR. That's the first step I need. Prove to me AB is parallel to PR. How am I going to do it? What am I going to need to find for both AB and PR? Slopes. Yep, making sure they're equal. All right, so somebody's going to be in charge of the slope of AB. Well, everyone is, but I'm just going to ask somebody. And then the slope of PR. You can do change in Y over change in X. You can plot A and B and do rise over run because you already have a graph with you. It's up to you. Hopefully you find out. They may not be the same when you write them down, but if you reduce them down, hopefully they'll end up being the same slope. All right, turn it back over to you. Slope of AB, what would it come out to be? 2/3. And the slope of PR? It was 4/6, right? But reduced down to 2/3. I still need to write what here? That doesn't show me anything. Rose? There you go. I need a little summarizing here. AB parallel to PR because slopes are equal. Second half of this, show me PR is half the length. I'm sorry, show me AB is half the length of PR. So AB is 1/2 the length of PR. What are you going to have to use here? Distance, all right. This is why I love this one. We get to review the two formulas. Actually, all three formulas, huh? x2 minus x1 squared plus y2 minus y1 squared. So we're going to go ahead and do the distance of AB, and then we'll do the distance of PR. Anybody finding distance of AB? Distance of AB. Square root of 13, I hope, for AB. And then when you do the PR, square root of what? Square root of 52, yeah, but 13 is not half of 52, right? What do you suggest I keep doing? That's not, 13 is not half of 52. We didn't do anything wrong. You just got to keep doing what to radical 52? Simplify the darn thing. Anybody know what perfect square goes into 52? 4, yep, times. Oh, look at that. And that'll be equal to 2 square root of 13. So just real quickly, show me that, radical 13, is that equal to half of 2 times radical 13? All right, just substitute it in, and what do you notice? Radical 13 equals radical 13. That's all. There's not really words you can tell me here. Questions? Not done. I got one more challenge question. Geometry name for that segment. Mid-segment. Mid-segment. When you connect the midpoints of two sides of a triangle, it's called a mid-segment. And using coordinate geometry, you guys just found out the 2 facts I need you to remember about a mid-segment. It is parallel to the third side and half its length. Half its length. Okay? Questions? Real quickly before we wrap it up. Let's just say you're at home. I totally blank on midpoint or distance formula. I had also given you a packet as you walked in today about cold hard facts that you need to know. Right? If you look on the very first page of that cold hard facts, in the middle you will see distance and midpoint formula. This is just basically a summary, a 6-page summary of the last 40 weeks. Okay, if you just go through it, you'll see transformation rules, you'll see Hills and Sass, you'll see all our circle formulas that you'll need, how to complete the square again. Okay, so keep this handy with you as you start doing these Regents problems. You got your assignment sheet, you know what problems are going to be due for me tomorrow. You can check them on JMap, or you can now check them on the other website I posted on Aspen, which gives you the video solutions.